Okay, good day po. My name is Rainier Francis E. Espinola from BSEC 3, Bachelor of Science in Electronics Engineering, third year. So this is the fourth episode of our series wherein I will discuss the different laboratory activities on our subject, signal, spectra, and signal processing. So yung laboratory activity 4 po natin is titled Digital Signal Amplitude Transformation. So yung laboratory activity 3 natin is all about time transformation. However, itong laboratory activity naman to is will focus on the amplitude naman. Amplitude transformation rather. So by the end of this activity, students should be able to generate a discrete time signal using Python, apply amplitude transformation such as amplification, attenuation, and inversion. So lastly, visualize and analyze the effect of amplitude transformation on digital signals. So a little background ulit to these activities that amplitude transformation is the modification of the signal's amplitude by applying a scaling factor or inversion. Kap- Kapag sinabi nating amplification, that is increasing the signal amplitude by multiplying with a factor greater than 1. Kapag attenuation naman, we decrease the signal amplitude by multiplying the factor between 0 and 1. When we say inversion, that is reversing the signal by multiplying with -1. Such transformations are widely used in signal conditioning, volume control, volume control in audio processing, and digital communication system. So let us now proceed with the program. So again, we have the import numpy, or we have the library, the numpy and matplotlib. For numpy, that is used for numerical operations and array handling. The matplotlib is for plotting the signals. So first off, we have to, uh, let's just run the code para makita na natin yung uh, output or figures to be observed. Okay, please, ayan. So let us focus first on the original signal itself. So we need to introduce a variable and ito yung nagde-define ng uh, range ng ating discrete time signal. So meron siyang from 0 to 19. Next is we define the sinusoidal signal. Yan. So yung original signal natin is a sinusoid but it is a discrete signal. Hindi siya continuous. As you can see here in our screen, yung figure natin, original signal. Yeah. So the stem, this n is the value of samples, and x is for the amplitudes. Yeah. Yung amplitudes niya is yung sign. Tama. Tama. So we need to add titles, tables, and then we need to apply the grid as well as the footer for signature, site layout to adjust the layout, or to avoid overlapping of our plot, and then to display the plot. And the original signal natin. Then let us proceed with the signal transformations now. So ang ginawa dito is that pinagsama na siya sa isang figure for us to determine or to observe, to compare rather, the three transformations, namely the amplification, the attenuation, and the inversion. So kapag in-exit natin to, makikita na natin yung tatlong plot or yung tatlong graphs. Ayan. So first off, this is the amplification kung saan dinadagdagan natin or we increase the amplitude. Here is the attenuated signal or attenuation wherein naging 0.5 na lang siya from 1 naging 0.5. And dito naman is the inversion wherein nag-start na siya from negative. So para in-inverse niya yung sinusoidal signal natin. Okay. So paano yung nangyari? We know that the amplification is that we increase the signal by multiplying a factor that greater than 1. So, we multiply it by 2. Sample lang to 2. Then, kapag attenuation naman, multiply natin siya by a factor that is 0 to 1. Yes. Pag inversion, we multiply it by amplitude by -1. So it flips the signal across x-axis. Hindi na to by the yeah, vertical na siya yung pag-transform natin. So in order to plot these signals, ayan, figure text. So we create a figure with specific size and yung size niya. So as you can see, yung plot natin, exit ko na pala. Sorry. Okay. As you can see, yung figure natin, yung buong figure natin, consists siya ng tatlong uh, plots. So we need to create subplot para mailagay natin siya sa isang figure. So first off, yung first subplot natin, which is the position 1, it divides the figure into 3 rows, kasi 3, kaya naging 3 rows and 1 column. And yung first graph natin, or the amplified signal, is at the first block. Kaya siya 1. Ayan. So stem, for digital discrete signal, I mean, rather. So meron siyang baseline that is K, kulay black. And then, ito, we add titles and labels. Itong block na code na to. Then we need to add grid for better visualization of the values. Same lang yun sa next signals, which is the attenuated and the inverted signal. But then, nasa second plot na to, and ito, nasa third plot na. Okay, so we need to add footer or signature. Then tight layout para hindi mag-overlap to avoid the overlapping of the plots and display the plots. So yun yung uh, origin nitong figure na to. So let us proceed now with the expected results. So the amplified signal will appear taller compared to the original signal. As you can see, naging 2 na siya instead of 1. And from -2 to +2. Tumaas na siya yung signal natin. Then the attenuated will appear shorter. From 1, naging 0.5 na lang siya to -0.5. And inverted, bumaliktad na siya. The signal flips or will be mirrored image, but flip vertically. And now let us proceed with the guide questions. What happens to the signal when multiplied by a factor that is greater than 1? We know this as the signal amplification. So the signal becomes larger, or it is the amplitude of the signal becomes amplified. Next is to compare the energy of the amplified and attenuated signals with the original. So answer natin dito is that the amplified signals have more energy than the original, while the attenuated signals have less. So third, what is the physical meaning of signal inversion in real-world systems? So yung inversion of the in amplitude transformation, ang nangyayari kasi sa signal is it becomes upside down, which can represent a phase reversal in system. So nire-reverse niya yung angle phase ng ating signal. And lastly, how can amplitude scaling be applied in audio and communication systems? So na-apply natin siya in order to control the volume of the audio signals and to adjust the signal strength in communication system. So that concludes our laboratory activity for digital signal amplitude transformation. Thank you po.